In this video, you will see a classic physics demonstration. Here you see a spring-loaded device which will shoot the ball on the left to the left with a horizontal initial velocity. The ball on the right falls with zero initial velocity. I want you to consider which one you think will hit the ground first. Welcome to Hovercraft Physics and Chemistry for a video on projectiles. Specifically, we'll do a horizontal launch analysis. Hopefully you've made a prediction about which ball you think will hit the ground first. I'm going to first play this at full speed. It will probably be hard to tell which ball hits the ground first visually. However, if you listen, you will hear a click when they hit the ground. I'll play that one more time. Notice when they hit the ground, there is not a double click. You hear one click. Now let's look at that more slowly. This is the frame just before launch is initiated. Both balls are sitting in the device. One frame later, the ball on the left has been kicked towards the left, and the ball on the right, although it doesn't appear to move yet, is now under the influence of gravity. If we watch it in slow motion, it may appear that they're not at the same height. But watch what happens here. At this frame, it may look like the ball on the left is lower and the ball on the right is still above the ground. But here's the very next frame. You can see that the ball on the right has bounced up and the ball on the left has bounced along the ground. Let me show you that again. I'll back up first. Right before launch and launch. This is where they've hit the ground, and the next frame they've bounced. This video is in standard definition, which means each frame is 1/30th of a second apart. That's a pretty small amount of time, and it does look like the balls hit the ground simultaneously. So the question should be, why do they hit the ground at the same time? I would guess a large majority of people would expect the ball moving to the left to stay in the air longer. There's just something about that sideways motion that makes it seem like it should stay in the air longer than the ball that drops straight down. Let's consider the physics going on once the balls are launched from the device. Once the device is initiated, the ball on the left has a velocity horizontally to the left. The other ball starts with zero velocity. It's not moving up, it's not moving down, it's not moving left, it's not moving right. So let's think, once they leave the device, what forces are acting on each ball? You'd probably guess that it's gravity, and you're correct. We're going to assume here that air resistance is small enough that we can ignore it. So if gravity is acting on each ball, that means that they're accelerating at g. Little g here means acceleration due to gravity. A little side note, if I was king of the world, I wouldn't call it little g. I would call it a subscript g, because it's just an acceleration. People sometimes get mixed up the force of gravity and the acceleration caused by gravity. Of course, we know that the value normally used for acceleration due to gravity is 9.8 meters per second directed downward. So let's look at the next frame. Both balls now have some downward velocity. The ball on the left is still moving to the left. There's no force to accelerate it left or right, so it maintains a constant velocity to the left the entire video. The next frame, they've gained a little more downward velocity. Again, that ball on the left is just moving to the left at steady speed. It's speeding up in the downward direction, just like the ball that's fallen from rest. As we continue, we can see that the trend is maintained. The ball on the left moves steadily from right to left, gaining speed in the downward direction. The ball on the right is only moving downward, and it's gaining speed in the downward direction at the very same rate. As they fall, that downward pointing vector gets larger and larger. And then this is the point where they hit the ground, and again, the next frame, they're bouncing upward. Because neither ball starts with any velocity in the up or down direction, they're going to hit the ground at the very same time. Let's see that one last time with the vectors, just a little bit faster. This is the frame right after they've been launched. And again, they hit the ground at the same time. Thanks for watching. If you enjoyed this video, please consider subscribing and sharing. Thank you.